Welcome to this explainer. Today, we're diving into something totally fascinating happening right beneath our noses, or I guess right behind our screens. We're unpacking Netflix's highly technical, yet completely invisible back-end video processing upgrades. Honestly, it's a masterclass in how machine learning is quietly revolutionizing the way we consume media.
So let me ask you something. Have you noticed Netflix looking, well, a bit better lately? Think back over your last few months of watching. Maybe you were camped out in front of a high-end 4K OLED TV in the living room, or maybe you were just catching a movie on your tablet during a flight. Did the shadows seem a bit deeper? Did the colors pop just a little bit more? And all without your internet sputtering to a halt? Sparing you from that collective groan we all let out when a video suddenly pauses? Well, if you felt like the picture was crisper, your eyes absolutely weren't playing tricks on you. There's a very specific, highly engineered reason for that. Here's our roadmap for today. First, we'll look at the 4K streaming challenge. Then, meet HDR VMAF. Compare fixed versus dynamic encoding. Check out the open source engine, and finally, wrap up with the viewer benefits.
All right, part 1, the 4K streaming challenge.
Let's set the stage with a bit of business. Specifically, the massive bandwidth friction and insanely high server costs of delivering premium video files. Netflix recently bumped up the price for its highest quality, ad-free premium tier. In the US, it went from $19.99 to $22.99 a month, and over in the UK, it went from $15.99 up to £17.99. Now, price hikes are never fun for anyone, right? But what's happening behind the scenes is that Netflix has been rolling out a massive technology upgrade to offset that cost, delivering tangible value to really justify that top-tier subscription.
What's kind of wild about this upgrade is Netflix's stated goal. It sounds like a total paradox. They set out to, quote, reduce storage footprint and internet data usage, and most importantly, improve the video quality for our members. Think about that for a second. In the digital video world, if you want higher quality, you almost always need more data, a bigger, heavier file. But Netflix set out to do the exact opposite, give us a vastly superior image while actually chewing up less internet data and server storage.
Which brings us to part 2, meet HDR VMAF.
So, we need to understand what VMAF actually is. This is our invisible, algorithmic hero working tirelessly to solve that massive streaming challenge. It stands for Video Multi-Method Assessment Fusion. Yeah, I know it's a mouthful, but it's an Emmy-winning mouthful. Simply put, it's a perceptual video quality assessment metric. Instead of just measuring video quality based on the display you happen to be using, VMAF measures quality based on the characteristics of the content itself. And what's brilliant is that this new HDR variant is totally format agnostic. That means it works equally well to independently measure quality whether you're streaming in Dolby Vision or HDR10. It calculates scores based on an ideal display that represents the entire luminance range and color gamut of the video signal.
But how do you actually develop and test a metric based on human perception? Well, it wasn't easy. Netflix announced VMAF back in 2020, but the pandemic completely derailed their in-person testing. So they had to get creative. They partnered up with Dolby Laboratories to run subjective tests using real 4K HDR content. And instead of using a sterile traditional lab, they tested this on high-end OLED panels right inside participants' actual homes. They set up perfectly calibrated viewing environments in standard living rooms because they really wanted to see exactly how everyday people perceived visual fidelity and detail loss in the real world.
Moving right along to part 3, fixed V's dynamic encoding.
Historically, streaming platforms relied on something called fixed bitrate encoding, which applies predetermined bit rates universally. Think of it like buying one-size-fits-all clothing. Sure, it technically covers you, but it doesn't look great and it's terribly inefficient. This new technology, driven by VMAF, is called dynamic optimization, or DO. It analyzes the specific signal characteristics of the video scene by scene to tailor the encoding. To stick with our analogy, dynamic optimization is like a perfectly tailored suit. It uses exactly the amount of data needed for that specific scene, optimizing perfectly for both quality and efficiency. And the efficiency we're talking about isn't just a tiny bump, it is absolutely staggering. By switching over to HDR dynamically optimized encodes, Netflix now only requires 58% of the storage space compared to their old fixed ladder encoding. They're saving 42% of their space. When you multiply that by the millions of hours of 4K HDR content sitting on Netflix servers all over the globe, that reduction in storage footprint and bandwidth is just monumental.
Next up, part 4, the open source engine. Now, you'd probably assume a competitive advantage this huge would be locked away in a corporate vault, right?
But surprisingly, this proprietary machine learning tech is actually a highly collaborative open-source project hosted right on GitHub. The C and Python libraries for VMAF have been continuously evolved by contributors. After VMAF was announced in 2020, they released version 2.0 by December of that same year. That version hit a 2x speedup over the older one by using x86 SIMD optimizations, which is basically just a fancy way of saying the processors could handle multiple data points at the exact same time. Fast forward to the first half of 2022, they started upgrading the library, and by June 2023, the entire Netflix HDR catalog was fully optimized with DAL. And the development hasn't stopped. Just in December 2023, version 3.0.0 was released to squeeze out even more speed and squash a few final bugs.
Finally, Part 5. The viewer benefits.
So, sitting on your couch or stuck on a long flight, why should you actually care about any of this? Because of this number right here, 40%. Thanks to this algorithm, viewers now experience 40% fewer rebuffers. That means 40% fewer instances of staring at that agonizing spinning wheel of death, wondering if your connection just ruined the climax of your movie.
But that's just the start. Because this system is so incredibly smart, you get a lower initial bitrate, which actually leads to higher initial quality the very second you press play. There's lower play delay, so the show just starts faster. You get far less variation in video quality, so it's not looking super blurry one second and razor sharp the next, and incredibly importantly, you use way less internet data. That is absolutely crucial if you're streaming on a bandwidth-constrained device like a phone or a tablet over, say, spotty airport Wi-Fi. You're getting a vibrant, highly detailed, high dynamic range picture on your small screen without completely torching your data cap. It perfectly reinforces the real tangible value subscribers get from their premium tier.
We've seen how Netflix managed to pull off the seemingly impossible here, delivering 4K HDR video that looks significantly better while using drastically less data. As machine learning continues to completely rewrite the fundamental rules of data compression, how much more invisible magic can we expect behind our screens in the years to come? It really makes you wonder what else is possible. Thank you so much for joining me for this explainer, and the next time you hit play and marvel at that perfect picture, you'll know exactly the invisible hero making it happen.